The simplest organic molecules are the hydrocarbons. Hydrocarbons are only made from hydrogen and carbon. We will start by naming straight-chain saturated alkanes. They are called saturated as all the carbon atoms have single bonds with other carbon atoms, and you cannot fit any more hydrogens on as they are saturated. The first is methane, and if we add a CH2, we get ethane, and another propane, and another butane. You can remember the first four by the mnemonic monkeys eat peanut butter. From then it's pentane, hexane, heptane, octane, nonane, and decane. You must remember the first 10 names in the series. Following butane, you could relate the names to that of polygons. Heptane has 7 carbons, and a heptagon has 7 sides. Chemical compounds are named according to IUPAC rules. Rather than go through all the rules, it is probably best to work with examples and apply the rules as we go. We will start with this molecule. The first thing we have to do is find the longest chain of carbon atoms. We have 1, 2, 3, 4, 5 here, or 1, 2, 3, 4, 5, 6 here. So the longest carbon chain has 6 carbon atoms. This decides the stem part of the name. The names of organic molecules have a prefix, stem, and suffix. As the longest carbon chain is 6, this will have the stem of hex. Here is a list of the stems for the different carbon chain lengths. Next we look at the branches off the main chain. We have a 1 carbon chain branch off the main chain. This is called a methyl group, and this forms the prefix. The names for the branches with the different numbers of carbons are as follows. We have to state whereabouts this methyl group is attached to the main chain, so we number the chain. We must number the chain so that the branch has the lowest number possible. For example, we could number the chain this way and go 1, 2, 3, 4, 5, 6, or start from here and go 1, 2, 3, 4, 5, 6. This way gives the lowest number for the branch, and so we put a 3 in front of the methyl to state its position. You must separate the numbers and the letters with a hyphen. Finally, we can apply a suffix. Our compound is an alkane, so has the suffix -ane. Our compound is 3-methyl-hexane. Now let's try with this compound. First we find the longest chain. The longest chain is 6, and so the stem part of the name is hex. Now let's look at the branches. We have a 1 carbon branch and a 2 carbon branch. These have the names methyl and ethyl. Now let's number the chain to get the smallest numbers. We could number this way, which has our branches on positions 3 and 5, which gives a total of 8. Or this way, which has our branches on positions 2 and 4, which gives a total of 6. We'll go with this, as this gives the lowest total. So we have 2-methyl and 4-ethyl in our prefix. We put our branches in alphabetical order, so ethyl comes before methyl. So we have 4-ethyl, 2-methyl as our prefix. Finally, the suffix is -ane, as our compound is a branched alkane. Our compound is 4-ethyl, 2-methyl-hexane. Alkenes are hydrocarbons with 1 or more carbon-carbon double bonds, and because of this, they are unsaturated. You can name these in the same way as alkanes. The difference is the suffix will be -ene rather than -ane. Also, in cases where the double bond can go in more than one place, you need to state the position of the double bond. With propene, the double bond can only go in one place, so you don't have to state its position. However, with butene, the double bond can be in position 1, and so this compound has the name but1-ene, or the double bond can go in position 2, in which case the name is but2-ene. Let's work through this example. The longest carbon chain is 4, so the stem is but. It has a methyl group on position 3, which makes the prefix 3-methyl. Now for the suffix. It has a double bond on carbon 1, so has the suffix 1-ene. Note, you state the carbon with the lowest number, so in this case you say 1-ene rather than 2-ene. So our compound is 3-methyl-but-1-ene. Compounds containing the halogens, fluorine, chlorine, bromine and iodine, are treated in a similar way to alkyl branches. They form the prefix of the name, and like alkyl branches, you must state their position. So let's look at this example here. The prefixes for halogens are fluoro, chloro, bromo and iodo. The longest carbon chain is 4, so the stem is bute. It has a methyl branch and a bromine group. The bromine is in position 2 and the methyl position 3. So in alphabetical order, with the bromo coming before the methyl, we have the prefix 2-bromo-3-methyl. This compound is a haloalkane, an alkane with halogens, so has the suffix -ane. Putting it all together gives 2-bromo-3-methyl-butane. Functional groups are the part of the molecule responsible for the reactions. There are various functional groups, and these affect the suffix. Aldehydes have the suffix -anal, carboxylic acids, anoic acid, ketones, anone. But you do need to state the position of the C double bond O group, like you do with alkenes. Alcohols have the suffix -anol. Once again, you need to state the position of the OH group in alcohols where there is more than one possibility. Let's try this compound. It has a 3-carbon chain, so the stem is pro. There are chlorine, bromine and iodine atoms on positions 1, 2 and 3 respectively. Note how the numbering starts from the carbon with the chlorine rather than the iodine. This is because chlorine comes before iodine alphabetically. We then order the prefixes alphabetically, so we have 2-bromo, 1-chloro, 3-iodo. Finally, the suffix. The compound is an alcohol, so has the suffix -anol. However, there are 3 places the OH group could go, so we need to state it is on position 2 by giving it the suffix -an-2-ol. Altogether, the compound is 2-bromo, 1-chloro, 3-iodo, propan-2-ol. Finally, we'll end with this complicated one. It has a 2-carbon chain, so the stem is eth. Let's work through the groups. There are 2 chlorines on position 2 and 1 on position 1. Because there are 3 chlorines altogether, we say trichloro, and to indicate their positions, we say 1,2,2 trichloro. Note how the commas separate the digits. Then we have 2 bromines on position 1, so that becomes 1,1-dibromo, and an iodine on position 2. Now we place these groups in alphabetical order, and we ignore the prefixes of tri and di that go before the group names. So we start with the bromines, then the chlorines, and finally the iodine. The compound is a haloalkane, an alkane with halogens, so the suffix is -ane. 1,1-dibromo, 1,2,2-trichloro, 2-iodo-ethane.